How you doing today, Robert?
Good, good.
Introduce yourself, please, and your talk for those who don't know
Hi.
you.
I'm Robert. I've been part of the D community for some time now. Maybe you've seen me somewhere. And for the last 2 years or so, I have been using GraphQL for work. And as D is the best language, there needs to be a GraphQL server implementation for D. So I implemented one. And the talk is about that. And well, actually, the talk is not about how to implement your GraphQL backend. The talk is how to use it, because the interesting bits are done. And as the title says, we have to do the boring bits, which are actually quite interesting as well. Clickbait title and all.
Well, the talk itself is not boring. I can say that. I've seen it enough.
Thank you.
But I had no idea what GraphQL was before I came into this, and I didn't really allow myself time to dig into it beforehand. So I'll leave it to you to explain what GraphQL is. And aside from D being the best language, what benefit does having GraphQLD bring to us?
Basically, when you think about GraphQL, think like a REST replacement that is borrowing quite a few things from SQL without borrowing the syntax. So basically, when you write a request to a backend, you can define what kind of data you want and how that is supposed to be. So for instance, maybe you only need the email address of a person, but not his forename or surname or some other information, and you can only request that thing. So in traditional REST backends, you would have to create one endpoint per request schema you want to request. And GraphQL pretty much gets away with all of that. So you can, as we like to be in the D community, very lazy about what you have to implement. I'm all for that. And actually, it's sort of the new trendy request language that is sort of bubbling up more and more in the web world. It was initially developed by Facebook for Facebook, but since, 2015 or 16 or so, they are publishing like a specification for the language itself. And it has been implemented in pretty much all languages. And yeah, I like it a lot. It gives you enough flexibility to get your job done, but it's not as easy to kill yourself with it as it is with SQL. So yeah, a good compromise, I would say.
Oh, I hated SQL back in the day.
Yeah, like I absolutely understand the hatred for SQL, but on the other hand, it is an extremely powerful language. At work, we use Postgres to basically populate the data we return with GraphQL. And yeah, Postgres is just, the performance of it is just awesome.
I did go spelunking a little bit through the GraphQLD code base, and I noticed the initial commit was in August of 2017.
Yeah.
And that's quite a while ago. And so this is before you started with Symmetry, right?
Yes. Like I was interested in GraphQL quite early because I have a profound hatred of REST, as you have a profound hatred of SQL. Probably not because REST is bad, but the way I got exposed to it wasn't so nice. I think I was actually at a conference at the time. And as you do as a conference, when the presentations aren't as good, you say, well, let's see what else is out there. And I had a look at GraphQL and was thinking, this is interesting. And at the time, I was really into parser generators. And I looked at the grammar from GraphQL and realized that it probably fits into LL1 grammars. So I was thinking, well, let's first create a parser generator, because that is obviously the quickest way to get anything done, which it's not. So I created a parser generator that is good enough, I would say. And then created the grammar, basically copy pasting it from the spec and generating the first parser. But then reality struck again, and the conference I was at was over, and pretty much nothing happened for a while. Then, I was done with university and started working for Symmetry, and realized that I was basically creating REST interfaces and found it very annoying. And the worst part about it was I had to do quite a bit of front-end development to shape the data I wanted to present in the front end through JavaScript observables. And I never really understood how to chain those, as the asynchronicity of them are really strange and difficult to use, at least for me at the time. So I was thinking, well, I had this GraphQL thing and this looks like I can reuse it. And I talked to my manager and said, hey, GraphQL. And he said yes, and off I went and sort of implemented the backend for it. Obviously, it took a lot longer than I hoped for, but I got it done eventually. And the cool part was, after pretty much the GraphQL thing started working, I was able to delete most of my front-end code. And right now, the biggest part of the project is just HTML to display the stuff I get with GraphQL. Yeah, that's how this project started and then continued.
I looked, not thoroughly, but I glanced at the code, and I was looking for to get a sense of how heavily you're using these metaprogramming features. And my initial impression was that it's not as heavily as I would have expected.
There are parts of it that are quite heavily using it. So the cool thing about GraphQL is that it's fundamentally strongly typed. And basically what I do is you provide a destruct with all the entry points into your graph. And then there is metaprogramming that iterates all those functions and iterates all the return types and parameters to these functions and translates them into the GraphQL schema that you can export. And also you can use the GraphQL API to query the schema itself, not only the data, but also the schema. And all of that is generated from the destruct and the member functions of it. So there are some bits of the GraphQLD implementation that use it very heavily.
The schema package is where I saw most of it. You've got the introspection types file and there the two schema file. But but I was still expecting a lot more than it. It just seems like this is the kind of thing that would need it. So the reason I ask is because when you started working on this 4 years ago, were you as heavily into the metaprogramming as you are now?
To a degree, yes. I think since then my code has become more functional than it was at the time. So at the time, I wasn't using STD algorithm and range as much, but the metaprogramming, I would say, was already there. The one thing that I didn't do with metaprogramming that could have been done is the parser generator is actually quite trivial. It's I think the project is 4,000 lines of D. And actually what it does, it generates the D files and then they are compiled. And you could have done that with CTF-E and mixins. But the error messages you can get when you actually compile the file are better than what you can easily generate from the CTF-E side of things. So GraphQL itself isn't too complicated. And turning one schema, aka the destructs and functions, into another schema isn't that difficult. When you look at the GraphQL schema, it's basically the return type is on the right side of the parameters, not on the left side. That's it.
Yeah, I like the syntax. Seems to be a fairly clear relationship on both sides. The only problem that I recall you mentioning in the talk was the issue about where you have the captain of the ship and the captain has a ship.
That's sort of the fundamental problem there. GraphQL comes out of the JavaScript world, and they don't have the idea of structs there and the known size of structure. It's all object, right? It's all classes. And when you actually want to use the structures of your schema in your D program, at some point, if you have those circular references, that just breaks down because the compiler can't infer the size of the structs. But as I showed, there are easy ways around that. And you can always use classes, which, how to put this, having GC angst isn't really a thing when you do network programming, because the network is always going to be the slowest part there. So you can always just use classes and move on with your life to do whatever you need.
So for those not watching the talk right now, what we're talking about is a ship struct having a member of a captain struct, and the captain struct has a member of the ship struct, both by value, not pointers. So his solution to that was the nullable
store.
Yeah, nullable store. Pretty good. And that's in your library.
Yeah, that's the smallest library you can imagine. It's basically an empty struct that has an alias to the template parameter to easily get its name or its type.
What are your compile times like?
For the project, the work project is about 50,000 lines of D, and an incremental build 7 seconds or so. Not too bad compared to other languages, but still I would say an order of magnitude too long.
Yeah, that was my next question. Where's that on your frustration scale?
Frustrating enough. I mean, considering the rant I wrote recently, frustrating enough, I would say.
I have to ask while we've got them here, Razvan and Walter, what are your no-go compile times? Where do you start getting really, red-faced and, steam coming out of your ears when you see a compile time? What's the magic number for you?
It really depends on the amount of code that you're compiling, but I want to note that in recent years, compilation of Phobos has skyrocketed. 5 years ago, when I started working, I would just type the command and like in 1 or 2 seconds, you would compile both the runtime and Phobos. But right now, it's like half a minute or something. I'm just pulling these numbers out, but it's a lot. Especially when you're doing development, it really eats your time. And if you start compiling the unit tests, then it's like, 15 minutes or something.
Well, to me, it's too long. If, I press the enter key at the end of the command line, and by the time that the key rises back up, if it hasn't finished, then it's not good enough.
I did not expect that from an old C compiler. You're not an old C compiler. An old C programmer, a veteran C programmer like yourself. Has that always been your thing?
I've found that every factor of 10 in compile speed is transformative in how you write code. I started in the days when you submitted your card deck and then you came back the next day and you got a printout. So you were very careful about sort of hand compiling stuff to make sure that you didn't make a stupid mistake, which would cost you a day in turnaround time. And then we got to paper terminals where it would print things out, the ASR33, and those were slow. But and in the 80s, we had floppy disks, and their compile speed was everything because, listening to that floppy disk grind away was very annoying. But the problem is, as the compile speeds went up, the size of the code people are trying to compile goes up in proportion. So you always seem to be stuck in about the same length of time it takes to compile the code. So it's a constant problem. And the other problem is the decompiler is very fast. And so people think when they're making enhancements to the decompiler, they don't have to worry about speed. And so it's constantly slowing down as pull requests are added to it. And then every once in a while, somebody goes through and profiles things and speeds it back up again. So it's a constant struggle. But, if I have to get up and go get a cup of coffee or do something else for a while it compiles, that's a big problem because it breaks your concentration and your train of thought when it takes that long. It really should be a key click to compile.
We were talking about that in the BeerConf yesterday, and I don't think D is a coffee cup compile language. I know I've heard that a lot about C++. I think D, our compile times. Yeah, I mean, if they increase, I can see how that's frustrating. If it's longer than what it was before, you're used to what it was before, and now it's not there.
Well, the test suite is a major gating factor for me because the test suite takes so long to complete that I've gone off and I'm working on another project by the time it's done, and then it takes me a while to get back into what I was working on before. When it's so long, the delay that you're working on another project by the time it finishes, which is what happens with our test suite. That's a real productivity killer.
Yeah, but the DMD test suite, it doesn't take too long because of compilation times. We can improve it. Like if we would use DMD as a library to test some of the stuff, it would be much faster. But currently we're spawning a process for each file, right? So I think that is the overhead in the DMD test suite.
Well, when we originally did the DMD test suite, I combined as many tests as possible into one file because it wasn't the number of tests that was causing the delays, it was the number of files. So the fewer files in the test suite, the faster it ran. That's sort of fallen by the wayside, but it would be a productive thing to do, to go through at least the smaller files in the runnable directory and merge them into one larger file. It'll run a lot faster if you do that.
My next question, we're looking now at the resolvers, and you're using delegates for all of this, and I'm wondering what your memory usage is like, not just compile time memory, but your runtime memory usage.
When the project has been running for a day, 10 megabytes, so little I don't care. Don't care at all.
Can you talk a little bit about how you guys are using this in Symmetry?
Yeah, sure. It's basically an HR app, like storing information about people. And obviously, at some point, that information is also required by other parts of the business. Like Git is fundamentally an idea that is required in all domains, but you don't always want to use Git. So You use something else, and hopefully you have an API that people can use, and this is it. When I studied computer science in university, there was always the joke that we all end up implementing an HR database as sort of the place where you don't want to be. But actually, if you are in that place and you do something like a little bit novel, is actually very interesting. There are many aspects where you can find interesting work there.
My next question for you is about the Star Wars package. What's the deal with that?
Sort of the default test suite for GraphQL is basically the Star Wars movies and the characters and planets. And there's also the first suite I had is Star Trek, because obviously Star Trek is a lot better than Star Wars. But at some point, I also tried to or implemented the interface or the schema that was used by the reference implementation of GraphQL. So that is the Star Wars part. But I think the Star Trek schema has a lot better test coverage.
I thought that was something you did. I didn't realize that was a GraphQL thing.
No, I think there are nerds everywhere in this space.
Yeah. I'm going to ask you, did you have any big problems in the implementation over the years? And I guess anything besides the circular references?
Not really. I mean, every once in a while I had an undefined reference when linking, but usually like the Pragma Mangle was able to allow me to hack around that. But those have gotten fewer and fewer over the time. After I understood how to actually execute a query such that the resolvers get called in the right order, the rest is easy. I mean, the main implementation file is, I would say, fairly small. And yeah, it's basically hydrating and extracting data out of JSON objects. It's nice and boring, actually, and it works. And that's what you want, right?
Max says here, I think I've rediscovered a big source of these undefined refs when metaprogramming.
That is good. I mean, I think in the work project, I have 2 or 3 left, which are kind of annoying because I really searched for the call to them and there shouldn't be any call to them. And I'm not sure why they end up in the final binary. Even if it's like a non-debug release binary without unit tests, I don't know. But yeah, as I said, working around that, I have learned over the time.
How has the code base evolved since the early implementations to today?
Steven Spikehofer did a big push to decrease the amount of memory used during compilation in the reflection package. But other than that, the code is, as I said, fairly small. I mean, the parser is generated from an extended Bacchus-Naur form, and that is the most boring code ever. It's basically a bunch of nested ifs and seeing if the next token is what it's supposed to be or not, and then some string concatenation. GraphQL isn't actually that difficult of a language, so the implementation is somewhat small.
I didn't ask you this at the beginning, I don't think. What was the motivation for this talk? Why did you pick this one this time?
It's basically 2 or 3-fold even. So when I implemented GraphQL, I looked around at the other projects and saw that quite often they had very big teams, and doing it in D was comparatively easy, I would say. And when I looked at the usage of the packages in other languages, it really seemed like the interfaces seemed to be very annoying and you had to type a lot, and D is just nice for that. Then as you basically showed, the knowledge of GraphQL as a technology isn't widespread, and I found it to be a very productive technology to get stuff done. I would imagine that I'm not the only programmer that likes to be lazy. And then it's always good training to give a presentation. When I go back to my first presentation at the first DConf in 2013, it was a pain for myself to watch myself giving it. I rewatched it a year later, and I could watch 5 minutes at a time, and then I couldn't look into the mirror for a day or two. It was horrible.
Never watch your own talks.
Actually, from that moment, my advice to all the students, which also had to give presentations for the thesis, was
watch your talks.
Yeah, it's Friday night, you're alone at home, it's dark, get the blinds down, open up your laptop, record yourself while giving the presentation and watch it and delete the file afterwards. And a couple of students actually did it, and they said it was the most terrible experience in their lives, or their university life, basically. But it was very good. And you could basically see, from the first presentation they gave to the second or third one, when they actually did it, because all those small ticks you have just as a human given presentation, which are sometimes very annoying, just go away. So I make sort of a habit of watching my own presentation, even though it's painful and your self-esteem is going into the dumpster, basically.
He says the most difficult and hairy metaprogramming part of GraphQLD is cataloging all the possible types, since GraphQL requires a reflection API.
Yeah. So basically you have to take like the return types of all the functions. And then like if it's returning a nullable or an array, you have to get the type that is wrapped by the nullable or the element encoding type. And then you have to introspect those types. So if it's a struct, you have to iterate those members. Make sure that you don't accidentally also look into the like op equals or compare functions and op to string. And then you want to get the return types of those functions if they are available, if they require additional parameters, and also do the unwrapping. Then you have to unique all those types. So if you have like, don't know, the ship type at that stage probably shows up like 10, 15, 20 times in the alias sequence. So you have to unique them. It's really down the rabbit hole there.
So I assume that Steve contributed to GraphQLD because he's using it somewhere.
Yeah.
It doesn't seem like the kind of project you just, willy-nilly contribute to.
Yeah.
So aside from Steve, do you know of other people using it out there anywhere else?
Yeah, I mean, I'm working with Elijah on this project, and he is using it and he has contributed. And yeah, I think there are like 2-3 other people that have reported issues and therefore I would assume are using it.
So you were using it when you first implemented it, right? Back before the Symmetry days?
Well, actually, I wasn't using it too heavily. So big parts of the implementation were actually done while working at Symmetry.
You were intending to use it when you implemented it, right?
Well, when I started, I just did it out of pure interest into the language. And then at Symmetry, I was using like the traditional REST and observables on the front-end side to like get the data I needed and then display it. Especially the front-end programming with observables and the asynchronicity of it all was very annoying and required a lot of code. And I remember they had this sort of half-finished GraphQL implementation that would be a good fit. And then said, hey, can I take some time to implement this and then use it? And the answer was yes. And so I did.
Can you give like a scenario in which, an actual app scenario in which you would use this? You mentioned it.
Yeah, so for instance, one thing that is interesting is, let's say you have an endpoint where you get like all the currently working employees of a company. That would likely give you an ID for every person, because at some point you probably have like an ID, a unique ID for a person in a database. And then you want to get everybody's email address. And depending on how you do your REST interface, you would either have that email address already in the response for all the people you get, or you would have to do another request where you pass in the ID of a person to get his or her email address. And there's sort of the two schemes in REST where you sort of do a big interface where you overfetch basically, or you have to do many fetches to get like the data you're looking for. And then you have to display that on a web page. Quite often, if you use a framework like Angular, React, or whatever, that means that you have to present that data in a JSON schema of some sort. So either you already get that through the REST request, or you have to build it out after doing like all the nested requests. With GraphQL, you can just define like what you want, and then you get it in one swoop, and you pass that off to your HTML renderer and you're done. So like all this code of like either trimming out the data or collecting additional data through additional requests just goes away. You just have one request and get all your data. It saves you a lot of typing and then quite often also a lot of request time.
Elijah has a comment here. It's not a question. He says, I think more interesting than selections is the way you can chain, not select email then name, but select fields on employee and fields on employee's boss. Instead of first get employee, then get boss.
Yeah, and then get the email of that person. Yeah, and that's sort of where the graph part about GraphQL comes in. You can sort of link between the entities of your system, which also becomes at some point difficult because like if you don't validate, you can have nestlings as deep as fit into the request memory. And then you have to unravel that and send megabytes of JSON.
So you're the primary maintainer then now. Also,
yeah.
How much time do you spend on it?
I would say for the last half year, maybe 5 hours a month. Not that much, actually.
Yeah. So basically it's just the simple maintenance stuff. Brian says, have you thought about combining D plus GraphQL with some other kinds of output, like a D-based graphics output, maybe Elijah's text renderer?
Not necessarily, because basically the schema defines that it has to return JSON. But what I looked into a bit was generating a picture of the schema that you can request. So like a poor man's like SQL presentation of table relations, but that is more like for debugging purposes of the endpoints. It's fairly text-based, I would say, or fairly JSON-based. But I mean, pull requests are always welcome.
Would there be some way to integrate this into vibe.d, maybe as a
yeah, it's actually
plugin?
using Vibe. There's one part where when you have an array of things and you want to get subfields of that, there's a way to use the Vibe event queue to basically schedule one runner or one task for each element of the array, which speeds up the response a bit. And yeah, we are using it with Vibe. So basically what you have to do is get the request string out of the HTTP server request, and then you turn it back. I mean, you're returning JSON. So in the end, it's like write JSON from Vibe.
Is there anything else you want us to know about GraphQLD?
No, I mean, go out there and start using it. And if you have problems or pull requests, yeah, keep them coming.
We have a question from Alexander Heisterman. Robert, do you use other languages? I use C# for work.
Yeah, I mean, the front end is for the work thing is using Angular. And so we're using TypeScript, which also means we are using JavaScript. Yeah, that's sort of the main second language, I would say. And then obviously, as John has talked about at the last physical DConf, there is this internal language to Symmetry, which I also sometimes use. And we actually use that as the sort of second front end to the GraphQL, or the second user of the GraphQL interface, because basically whenever you have curl to call to some endpoint, you can quite easily call the GraphQL backend. Yeah, then you have JSON, and our internal language understands JSON. Like if you need special things in a special form and from our database, you can very easily do that with this special language through GraphQL. Other than that, I like to play with other languages, and I've played a bit with Elm, which is sort of also coming from like the functional usage of D. And Elm is very opinionated, but I think they have some good opinions, which I really like. And then also I used Svelte a bit to play around with, but that's not for work. That's just sort of me goofing around. It's always good to steal good ideas from smart people.
Ali doesn't have a question, but he would like you to tell us more about work at Symmetry, please.
Yeah, so as I said in the commercial break, we are looking for people. Over the last year and even before that, we have pretty much hired like people from all over the world. It is quite often very self-driven work. So like when obviously there are sort of things the company has to do, but how you achieve those goals is quite often left to yourself. And I mean, this is where the GraphQL implementation came from, right? Like technically, there was no reason to have a GraphQL backend. It was just me thinking, if I do this GraphQL thing, I can get more done in less time. And yeah, basically at that point, my manager said, okay, do it. If you think this is the right approach, then go for it. And I would say that is the experience that pretty much all the developers have made so far at Symmetry. Yeah, very kind, very hardworking people. As I said in the commercial break, if you're looking for an opportunity, shoot us an email.
Alex asks, when did you start programming? I started during high school using C#.
So actually, I started very late. So after high school in Germany at the time, you had to either do military service or like work in some social institution. And I worked in a kindergarten for 9 months at the time and had a C in 21 days book. And it probably took me 9 months to get through those 21 days because I was sort of sitting by myself in the basement, and pointers were like, yeah, I'm not sure how often I did that pointers day in that book. And so I started at that time. And then after that, I went to university to study computer science, and obviously the programming became a lot bigger part of my day, I would say.
My C book was a different C book, but the pointer chapter was the one that stumped me too for a little bit there.
Yeah.
But then once you get over the hump, it's like, what was the big deal?
Yeah, like in hindsight, it's all trivial, right?
It's there's nothing to it.
Yeah.
Peter asks, what are the prerequisites to working at Symmetry?
Having an internet connection and being able to think for yourself, I would say. Like if you can program, obviously that helps, but I think we're also looking for other professions. Like if you can show that you know what you're talking about when it comes to computers and programming, you have a pretty good chance.
Okay, so there's no requirements for degrees or anything like that, because you're basically on a contract and you're staying in your resident country. I don't mean you specifically. I mean people that you're hiring. They're not immigrating to the UK. They're
It's from all over the world. I think we are pretty much on every continent and in every time zone by now.
Yeah, and you guys have probably hired a significant percentage of the D community so far, which is pretty cool.
That's true.
Yeah. Another question from Alex. Robert, what new language features would you like D to have?
New language features. For the language itself, actually none. I would like to... I mean... How do I put this? I'm a very simple guy. I like my garbage collection and I like a fast compiler. That's it. I mean, most of the things that I would add are probably like either re-implementations of tools or things that would end up in libraries. Not that interesting.
Robert, final thoughts?
I should have prepared this. No, I mean, keep using D. I mean, it's the best language for everything.
Okay.
Thank you,
and
Robert.
We have... Yeah, D rocks. And before I let you go, Robert, we have one question got in just under the bell. Robert, sorry if this is too noobish, but how does GraphQL know to grab data from, say, a MySQL database?
Well, basically, because you have told it in the resolver how to get the data from your database. Yeah, that's sort of the boring part of the work you have to do to actually get the data. But with a little bit of metaprogramming, much of that can be automated. So like what we did is basically the schema that we represent through the API is pretty much the same that we have in the database. So generating the database request and then turning it into JSON is pretty straightforward.
All right. And now it is time to pick the winner of the T-shirt. We have, I think, 4 names in there to choose from. So let's see who it's going to be. Alexander.